Hello, thank you for watching this video about how we propose to revolutionize the solar industry through holography. I'm Dr. Chris Lobus and this is Dr. Gore Sarkeesian, and we're reaching out to you for financial help in launching the initial phase of our business plan, which is to construct an energy-producing holographic solar mirror prototype that is capable of fitting onto existing solar mirror and parabolic trough systems. We are choosing holography as the new technological method to advance the field of solar energy because with it, and our unique biological application format that we've developed, the sun's light can be manipulated at a nano level through diffraction and allows us to both absorb and reflect as much or as little sunlight as we choose at any angle and onto any point in space and on nearly any type of cheap yet durable materials such as glass, plastic, or polycarbonates. In fact, when adding holography to conventional configurations, a reflective solar mirror could achieve a 99% diffraction efficiency, which is much greater than anything solar mirrors are capable of achieving today. To show why our holographic technique is the right technology for the solar industry, we created one on this piece of glass. You can see that it actually contains more than one image and is completely transparent, which are key aspects. Multiple reflective holograms can be incorporated into a single mirror, which means that each mirror can be laid completely flat and collect full sunlight all day long without the need to rotate them on expensive tracking systems that solar mirrors currently do today, because a bunch of tiny nano-sized holograms are collecting the sun's light as it passes overhead. Also, you can see the intimate level of detail involved in this hologram, which speaks to the precision and accuracy that is feasible with lasers and nano manipulation. Finally, because it is built on glass, a much cheaper material than what is currently used on conventional aluminum solar mirror systems today, production and maintenance costs can be lowered, and the transparent nature of the glass also allows for absorption at the same time it is reflecting. With this capability in mind, we created this proof of concept model of a solar tower plant that uses our holographic solar mirrors instead of the traditional heliostatic ones. It demonstrates that our product may be applied to existing infrastructure, saving companies millions of dollars on their previous investments. You can see that when we turn our holographic solar mirrors that span out concentrically from the central tower, it illuminates and the reflection becomes more and more intense, just like a conventional system. But, unlike a conventional system, these holographic elements reflect the sun's light on a nano scale, meaning that the geometry of the physical orientation in each holographic mirror is completely irrelevant. They can reflect sunlight from any arbitrary angle onto any single point in space of our choosing. As you may see in this model, they are all laid flat, yet producing an intense reflection on the tower. Also notice that the reflected light changes colors. Because the holograms are built so precisely with lasers, they are capable of nearly any filter. For the purposes of presenting this visually to you, we built them to only reflect the part of the sun's energy spectrum that contains the usable, visible light for generating solar energy, which is why the colors on the tower are mostly red, green, and yellow hues. Now, our model isn't large enough to record any meaningful temperature data, so we decided to quantitatively show holographic solar concentration by measuring light intensity at the central tower. In doing so, we measured a 26% increase. Mind you, this is only with a few 3x3-inch holograms that were built in a garage with mediocre tools. Imagine what we could do in a proper lab with calibrated tables and a dust-free environment. So as you can see from our model, there are several significant differences with our holographic technology that are actually cost and space-saving advantages for the solar industry. To address them in further detail using the same solar tower example, conventional heliostatic mirror systems are positioned atop expensive mechanical devices that rotate the mirrors throughout the day along the sun's easterly rise to westerly set path. But they're expensive and complex to build and maintain, taking up large areas of space. Also, when the mirrors are raised, they overshadow each other and need to be spaced far enough apart to prevent this, which adds to the overall system costs to acquire more land. Furthermore, conventional systems often fail when they are subject to disruptions from the elements such as dust, debris, droppings, and wind, which results in off-target collection. Now, this could be avoided if solar technology advances, but sadly it hasn't yet and continues to yield detrimental impacts, many of which are beyond just reductions in efficiency. Outdated solar technology also has severe ecological impacts and creates negative publicity. The Wall Street Journal recently reported that the solar technology used by NRG, Google, and BrightSource Energy in their $2.2 billion plant in California, for instance, may very well be the last of its kind. This is because they are producing pockets of off-target collection where birds are flying into them and immediately burning up and dying. Not only is this a PR nightmare for these companies, it also calls for the necessity to find a solution now. Our holographic mirrors can be laid flat, where there is no risk of shadows from other mirrors overtaking them. And they can be positioned in nearly any spot, close together or far apart, yet still produce an acutely accurate reflection of the target light range on every mirror throughout the entire day. And they can reflect at any height, which saves on the cost of building and monitoring expensive tracking systems that routinely break. They can also be put much closer together, avoiding the need to purchase large tracts of land. And finally, the environmental consequences of misfiring can easily be avoided. And certainly not least, the other very important advantage of our holographic solar elements is that we are building them on our unique proprietary material that only we are capable of producing, that eliminates nearly all weather and environmental concerns, greatly saving on maintenance and replacement costs. The time to introduce this capability is now. Governments around the world are enforcing new guidelines to address climate change, and business and political leaders are pledging billions of dollars to modernize and grow environmentally friendly infrastructure, as evidenced by recent deals at the UN, ASEAN, and G20 summits towards the end of last year. From all of these agreements and pledges, there is a sea of available funding from organizations like the Department of Energy, the Small Business Administration, the DoD, and many others for anyone who is capable of reducing kilowatt-per-hour costs in order to feasibly generate eco-friendly power. With our technology, we have near total control of the sun's radiation that is used for energy production, which is unlike anything this industry has ever seen. Our holographic solar mirrors will be applicable to existing infrastructure and capable of capturing even more of the sun's light throughout the day, saving significant amounts of current maintenance work and time, as well as future production and acquisition costs. We are ready and motivated to incorporate the widespread use of holography into the formats and means in which capturing the sun's light will save companies money and space, and finally advance the solar industry to the technological pace in which it needs to be for us to make a significant difference. Thank you for your time, and please contact us if you would like more information on our plans or would like to help.